Okay, this is a trigonometry video on using the sum and difference formulas and how to rationalize those answers. So here we go, we get this given information. They tell us tangent of alpha is -4/3. They give us the domain of alpha. Cosine beta is 1/2. They give us the domain of beta. And I am going to find tangent of alpha minus beta. But first, I'm going to draw the triangles that correspond to alpha and beta. I'm going to be thinking about this on the coordinate plane. And when I look at the domain, it tells me that alpha is between pi/2 and pi. So I know that my angle is going to be over here in the second quadrant. Now when I go to draw my triangle, I can see and interpret the negative in tangent. So tangent, sine over cosine, and I know that my sine, my y values in the second quadrant are positive, so it's my cosine that's going to be negative. So I'm going to draw a -3. This would be 4, and this would be 5, and I know that because that's a special right triangle. Here's our alpha, and the tangent of alpha would be -4/3, where the negative value, again, is that x value, that cosine value that is negative in the second quadrant, and I knew that by interpreting the domain. Now, we can draw another triangle. So for beta, I see we're in the first quadrant because the domain is between 0 and pi/2, so we're somewhere over here. Okay, cosine of beta is 1/2. I'm going to draw my triangle here, and again, we actually have a special right triangle. You could also solve this unknown side using Pythagorean theorem. I have my alpha triangle drawn in red, my beta drawn in blue. Now the reason I did this is because when I look at my sum and difference formulas, I need more information than what they gave me. So I am looking for tangent of alpha minus beta. When I look at that formula, I have tan alpha minus tan beta over 1 plus tan alpha tan beta. Okay, we needed to draw the triangle for beta because we need the tangent value. So tan beta would be opposite over adjacent. So tan beta is going to be √3 over 1, which is of course just √3. So now we have tan alpha, we have tan beta. So you can see those are all the pieces of information we need to plug into our formula. So I'll go ahead and I'm going to plug right in. Tan alpha, they told us, is -4/3 minus √3. All of that is going to be over 1 plus -4/3 times √3. So I'm going to do a rewrite of both the numerator and the denominator. In the numerator, I'm seeking a common denominator, okay? So what's that common denominator going to be? Well, we can just choose to use the denominator that's already there, which is 3, all right? So we have -4/3, okay, minus, this would be 3√3 over 3. So I multiplied by 1 in the form of 3 over 3. Now, in the denominator, I'm just going to simplify a little bit. So we are going to have 1 minus 4√3 over 3. So we have a radical in the denominator we want to rationalize. Okay, so to rationalize, I'm going to multiply by the complex conjugate. I'm going to multiply by a form of 1, so I'm going to have something in the numerator divided by itself. I want to get rid of the radical in the denominator. I don't really care about what happens to the numerator. We have a difference here in the denominator. So instead of 1 minus, I'm going to do 1 plus 4√3 over 3 all over itself. 1 plus 4√3 over 3. I'm going to rewrite where we were, the step we were at, and I'm going to put it next to the complex conjugate. We were here. We are going to multiply by the complex conjugate. So I have to FOIL. First, I'm going to multiply these first terms. -4/3 times 1 just equals -4/3. Then I do the outside terms. -4/3 times 4√3 over 3. Well, I know it's going to be negative. And then I have the 4's get squared times √3 over 9, right? We have 3 times 3 in the denominator. First outside, now we have inside. Okay, it's -3 √3 over 3. And then last, going to be negative again, we have 12 times root 3 squared, which is just 3 over 9. Now we have the denominators, which is much easier because we crafted this conjugate to make the multiplication in the denominator easy, specifically to wipe out the radicals. I'm not going to show this whole multiplication in the denominator because it is a difference of 2 squares. If you don't understand the math that goes along with the difference of 2 squares, I'm happy to make a separate video on that, but this is just a difference of 2 squares. So we can do this multiplication in the denominator by squaring the first term and squaring the second term here. So we're going to have 1 squared, which is just 1, minus 16 times 3 over 9. Okay, so I had 4 times 4, root 3 times root 3, over 3 times 3. So now we can simplify further. What I'm going to do in the numerator, I'm going to get a common denominator. The common denominator I'm going to choose is 9. So I'm going to put everything in the numerator over 9. So I have negative 12 ninths minus 16 root 3 over 9 minus 9 root 3 over 9 minus 36 over 9. And then to simplify in the denominator, I'm also going to choose the common denominator of 9. So this would be 9 ninths minus 16 times 3 is 48 ninths. Okay, we're getting there. We can simplify here by doing the subtraction. So we have negative 48 minus 25 root 3 all over 9, right? So I did the subtraction in the radical fraction terms, and I did the subtraction in the non-radical fraction terms. And this is all going to be over negative 39 over 9. We have a complex fraction that shares a denominator. So the denominator here is 9, denominator here is 9. We can actually just cancel. And you'll notice we can also bring out a factor of negative 1 in the numerator and cancel that negative. Negative 48 plus 25 root 3 over 9 over negative 39 over 9. Now we can cancel the negatives and we can cancel the denominators. And now I have 48 plus 25 root 3 over 39. Okay, that would be the value of tangent of alpha plus beta. So going from the top really fast, now that my work is already there, I have a problem where I'm going to use the sum and difference formula with my trig functions. Okay, I draw my triangles to get my appropriate values. So I needed tan beta to plug in to my difference formula. I find that understanding where the domain positions me and drawing my triangle. Then I plug into my equation, but because I have a radical in the denominator, I have to rationalize. So I'm going to create a difference of 2 squares. I multiply by the complex conjugate. This denominator, I turn it into a sum instead of a difference. I multiply by it over itself. Okay, I FOIL the numerator and the denominator. Then I put everything in the numerator and the denominator over common denominators. In this case, they happened to cancel. I brought everything down to a simplified form here as such. Whew. Hope that makes sense. These problems are so very long. If you have any questions, drop them in the comments. I will take requests for any problems you want to see me work through. And with that being said, have a great week in math. Thanks so much for watching.